Okay, good morning everyone. Today we're working on inverse trig functions. Right? Inverse trig. And if you remember these terrible inverse trig derivatives, it's like the derivative of sine inverse wasn't a nice value. It was 1 over 1, the square root of 1 minus x squared. Okay? And the derivative of cosine, which was actually pretty easy because it was just the negative version of this. If I look at tangent, this one was a little bit weird too. It was almost like all of a sudden the world is at peace because all the square roots go away. Thank you for that. And then our cotangent version of this was just a negative version. Okay. You guys sadly remember these? And our last one, d over dx of secant, was a mess of a show. It was x squared of x squared minus 1. And now the way I remember this one is like, for some reason, I always relate things back to prison. It's like, this is you in prison and you're just looking out at your friends outside. X is always next to x. Okay? X is always as close as it can to be x. While the other one is always on the other side. Okay? And of course, sorry, go ahead.
Dove said that he's like waiting and he needs a password or something.
The password is math.
Okay, thank you.
Thank you. I thought I emailed him back already. I didn't email him back today. I emailed him back a couple days ago. Cosecant inverse of x is 1 over negative x. And remember, you write x squared next to it because it's like as close as I can be. There's Dove. Okay. All right. Now, if we can go forward, the idea is can we go backwards? And our goal is to go backwards today. Okay. So let me write you the identities and then we'll see how these play out. So the integral of du over the square root of a squared minus u squared is arc sine u over a plus c. Now, this does look a little funny. And we'll talk about why in a little bit. There is another identity where it's just 1. Just like our derivatives, but we'll look at that in a little bit. The next one is integral of du over a squared plus u squared. If you remember our derivatives, which derivative did not have a square root? And that was arc tangent. And then the same thing, u over a. But careful, this one else has a 1 over a in front of it. Plus c. And then our last one, the integral of du over u square root of u squared minus a squared. This was 1 over a arc secant of absolute value of u over a plus c. Okay. No worry, Dove.
Mr. Coat, what is all this?
It's hell on earth. Okay. What happens is, as we learned all our derivatives, how to go forward, and of course, derivative of sine was easy, cosine. The derivative of tangent is secant squared, easy. Derivative of secant, secant tangent, those are easy. You can memorize those. But you also had to memorize the derivative of inverse functions. And what happens is, we, in calculus, have gone pretty much through everything you did in algebra 2. Right? For how can I take the derivative of this or that? How can I deal with the slope of this or that? And along with that, in trigonometry is our inverse functions. So we have to say, what would happen if I took the derivative of an inverse function? Now going backwards, if I have this problem here, what was the integral of this? It was back to our inverse functions. And arc is another way of saying inverse. I see you shaking your head, but the point is that when you see a problem like this, you can't take an integral any other way because this is what the inverse is. This is what the integral is. Okay. All right, so let's look at a problem that's That I guess kind of easy-ish. So along with this, remember we can write arc as sine inverse. Okay, this is tan inverse, and this is secant inverse. Okay, write it also that way. So let's give ourselves some examples here, and see if we don't get lost along the way. The integral of 9x squared over the square root of 1 minus 9x to the 6 dx. Now you can save your hate for later, but let's see if we can figure this out. Now, the first thing I would naturally try, okay, me as a human, I would naturally try u substitution. I'll say, hey, what if u was equal to 1 minus 9x to the 6, okay? That's what I hope. I'm crossing my fingers. I don't want to say in prayer, but I'm crossing my fingers hoping to the calculus lords that this would work. Now, in your head, take the derivative of 9x to the 6, and does 9x to the 6 cancel out with 9x squared? No. So no one is blessing me this day. So we know that if I take the derivative of u, we end up with negative 54, which is not a big deal. But x to the 5th does not nicely cancel out this guy here. And if it did, u substitution, winner, winner. Move on with life. Easy exponent. Easy power roll. So this was FL. So we try something else, and we realize, well, I can't solve this in my typical integral way because it's inverse trig. This is an inverse trig problem. So instead we say, okay, what is close to this? The integral of 1 over the square root of a squared minus u squared dx. This is what we're aiming for. We're trying to make this look like this. Okay, how do I know is that version? My best guess is because it was 1 minus x squared, 1 minus x squared, constant minus x squared. This was going to be my version. It wasn't going to be tangent. It wasn't going to be secant. Okay, how do I know the other two? Take a look here. If it was tangent, there was no square root. If it was secant, it would be variable minus constant with a variable on the outside. Okay, so my hope first is that it's secant. Oh, sorry, sine. It's sine. That's my first hope because that's easier. So take a look here. We're going to have to declare a new u, and the u is not going to be 9x to the 6. That is not my u value. Okay, this is not my u value. We are going to say what would have been u squared here. If 9x to the 6 is u squared, then u has to be 3x cubed. Okay, if I'm saying u squared is 9x to the 6, u by itself, just straight u, is just 3x cubed. Now, here's where our u substitution happens now. Let's go ahead and take the derivative of u. Du is 9x squared dx. Hopefully you will notice that 9x squared and 9x squared might help out here, might simplify out.
Wait, why is u squared? Oh, never mind.
Okay, we start off as we're trying to steal this number here. That's my u. Okay, and then we're going to write du, sorry, not du, dx, is equal to du over 9x squared. All right, so let's go ahead and rewrite all their substitutions. This is the integral of 9x squared from here to here over 1 minus u squared, because we traded it for u squared, and dx is now du over 9x squared. Coolness here, because now we see that 9x squared and 9x squared divide out, and we have our rule 1 over the square root of 1 minus u squared du with this integral. It's pretty clean, right? This integral is is sine inverse of u plus c. That is straight. This part is a straight definition. Okay, that's our straight definition. That's from up here, right? We wrote arc. Now we write u over a. Fine. If I write u over a here, and it's u over 1. Because a is equal to 1. Straight definition.
Do you plug in
Yep.
the
Now we have to,
value?
yeah, you're right. You got it. Now we're not almost done, but at least we got the hard part done. We have sine inverse, darn it. Sine inverse of u. We said u was 3x cubed. And we can say over 1 if you want to include that, and plus c. Now, let's go back and do our derivative. If we take the derivative of sine inverse of 3x cubed, okay, let's take the derivative of this guy. The derivative of this was 1 over the square root of 1 minus 3x cubed squared. Do you guys remember that's the rule? Okay. Oh, maybe you probably don't remember. Okay, that's the rule. And then you chain rule. Chain rule it. 9x squared. And that's where we end up with our original problem. Easy peasy, right? That's where we end up with 9x squared over the square root of 1 minus 9x to the 6. Which is where we started from. Okay, right. So you can kind of see the idea behind it. Okay, so we're going to try a couple more problems and see where we're going to go from here. All right, let's try another one. Do you guys want to try another sine one? No? Let's try another sine one? Well, okay, well, we'll do it anyways. I don't care what Jacob says. This is integral of 2x over the square root of 25 minus x to the 4th dx. Do you think this would be a sine, cosine, no, sine, tangent, or secant? We're only going to deal with those three. Sine, cosine, or secant. Okay, we're only going to deal with these three for inverses. Sine, cosine, or secant. I see
Sine.
it's sine because 1 is a number minus x squared, right? Now, make a guess. What do you want to be your u? Your u can't be x to the 4th. So our u squared is x to the 4th. But so our u value is just x squared. Now, if I take the derivative of u, we end up with x squared. Oh, sorry, not x squared. We end up with 2x dx. And take a look here. This 2x, maybe, huh? Maybe, right? Gets rid of the extra x on the outside. Yeah, thank you. You can leave your tips in the tip jar. All right. Okay. Now, if I want to rewrite it, it's going to be integral of 2x over the square root of, I'm going to write this as 5 squared. So you can see the 5 squared minus u squared. Dx became, instead dx is now, I'll write this as a parentheses, du over 2x. And thank you 2x, you got rid of that extra baggage on the outside. We got rid of all our x's. Now we're talking the same language. Chinese to Chinese, right? U to U. And now we're left with the integral of du over 5 squared minus u squared. And this is a straight copy. This is a straight copy. For me, look at my identity now. Where a is equal to 5 and u is equal to x squared, just FYI. U is equal to x squared. This is sine inverse of u over a, which is x squared over 5 plus c. Okay, if you wanted to include the extra step, you could write sine inverse of u over 5, which is then plugged it in. Okay. Okay, so this one doesn't look terribly like death. All right, let's look at a tangent one. Dang it, I gave it away. But let's take a look at the tangent one. This will be the integral of 3x squared over 1 plus x to the 6 dx. Now looking at this problem, would that look like more of a sine, secant, or tangent? Sine, tangent, or secant? Okay. I see no square root. Okay, it might be tangent. Now again, if I was looking at this problem like normal, I'd be like, can I separate the fraction? Can I separate x squared over 1 plus 3x squared over x to 6? Answer is no. You can't do it, okay? Because that's stupid fraction. Right? You can't split it this way. So this is a fail. Can't do that. could I make u equal to 1 plus x to the 6? Sure, try it. And the derivative of this is 6x to the 5th, which does nothing to my 3x squared. Okay, oh, shoot. All right, so you're a fail too. I tried all my easy rules. You guys tried long division. We can do long division. 1 plus x to the 6 to 3x squared. That doesn't go into it. This is trash also. All right. So I guess it has to be inverse. So let's give it a shot. If we say our rule again is inverse of 1 over a squared plus u squared. This is going to be tan inverse of u over a. Okay, plus c. That's du. All right. So we want to make sure we call our u's out. U here will be x cubed. How did I get x cubed? Because u squared is x to the 6. So u squared is x to the 6, so u is just x cubed. Our a value, just so we have it, is just 1. Nice simple 1. But let's go ahead and take the derivative of u. Du is 3x squared dx. Hopefully you have noticed by now that the 3x squared is going to get rid of this other 3x nicely. So we only have one variable u. When you take the integral, you can't have two variables. So we're left with an integral of 3x squared over 1 plus u squared. And we're at du over 3x squared. Okay, if I'm going too fast, please let me know. Or if you're confused about any of the points, please let me know. Those divide out. And we are nicely at the integral of 1 over 1 plus u squared du, which is the straight identity for tangent. This is tangent inverse of u over 1 plus c. Running out of space, I'm sorry. This is tan inverse of u is really x cubed over 1 d, nope, no dx, what I'm talking about, plus c. You don't have to write the over 1 there. Okay. Again, these look terribly hard. And the thing is, if we didn't know that this was an inverse trig identity, we would never ever have been able to integrate this. Never ever ever. Okay, let's do another tangent one. Okay, let's kick it up a notch. So here's the next one: is the integral of 10x to the 4th over 4 plus 4x to the 10th. Okay. So there's a couple ways we can do this problem. We can get rid of this 4 right away. Okay. So just on the side, we could get rid of this problem. We could have simplified this. You don't need to write this, but FYI, what if I divide everyone by 4? This will be 1 over 4, the integral of 10x to the 4th over 1 plus x to the 10. Okay, we could have done that. Just FYI, just on the side, just throwing that out there. And this might be easier for us. Maybe, I'm just saying. Maybe. Okay. Or you could have simplified, doesn't 10 divided by 4 become 2? Right? We could have done that. There's a lot of things that we could have done with this. So you could simplify a lot. Yep, so I'm going to do another one of these right now. But let's pretend I'm not going to do any of that stuff. I'm just going to take it as it is. I'm going to take it like a man. I'm just kidding. I don't mean that. Take it like a x. Okay, here we go. So my u value is going to be what? Well, if u squared is 4x to the 10, du is 2x to the 5th, dx. Oh, sure. Oh my gosh, what am I doing? I'm sorry. I just mixed everything in my brain. This is just a u. A u is 2x to the 5th. And, come on, man. Come on, man. Du is 10x to the 4th du. There you go. So I ended up doing too many things in my brain at once. And lucky for us, ooh, whoop, wrong button. Ooh, right? That's going to clean up nicely for us. Will it always clean up nicely? Nope. But is it cleaning up nicely now? Yep.
Yeah, what happens when it doesn't clean up nicely?
The exponents must clean up. The exponents and variables must clean up. The constants may not. If the constants don't, you throw it on the outside afterwards. If there's an extra 2 after it, let's say extra 2, just throw it on the outside. That's just a constant multiple. But the variables all must clean up, so we're only stuck with one variable. If this was cubed, not enough. Find another way. Okay. So let's go ahead and rewrite this now. This is going to be over here the integral of 10x to the fourth over, I'll write that as 2 squared plus u squared, right? Because that's going to be our a value, or a is going to be 2, just so you can see that right now. And our dx became du over 10x to the fourth. How nice. The 10x to the fourth divide out, leaving me the only variable in this problem, which is we're all in agreement, this is all u now. Not me, u. So rewriting this, so it's going to be du over 2 squared plus u squared. We have a straight identity for this. This is tan inverse of u over a, which is 2. Yep, sure.
Don't we have to press do the plus C?
Yeah, plus c. I'm trying to think if there's anything else I forgot here.
Do we plug in 2x to the fifth into u?
Oh yeah. Sorry, I forgot one identity part. If you guys look up here, there is, for this rule here, where did I write it? Right here. There is a 1 over a in the front. Remember this 1 over a? Okay, there's that 1 over a for this version here. So let's go ahead and take that 1 over a out. So it's 1 over 2. Okay, there's that 1 over 2 in front. I was like, I'm missing something in this. Okay.
So you do that to the one above too?
The one above was actually a invisible 1 because the a value was 1. So this would be 1 over 1.
Okay.
Now, there is another set of integral rules where they instead write this. Instead of writing u and a, they just write, let me just give you guys, let me some space. Let me show you the other version. The other version is integral of dx over, no, let's try it another way. 1 over 1 minus u squared, 1 plus u squared, du is tan inverse of u plus c, okay? And the reason why they don't write 1 over a is because they have a 1 here. Okay, so it's always like 1 over 1 over 1 like that. That's the rule.
Do we plug in anything for u?
Yes, we always have to rewrite u, right? We have to write back the u. This is 1 over 2 tan inverse of 2x to the fifth over 2 plus c. If you want, you can simplify that 2 out. So there is actually a whole set of identities where it's just, instead of a, it's just 1. And another one is integral of 1 over u squared of u squared minus 1. If you notice that these versions only have a 1 in the front. Okay, these versions only have 1 in the front. But that's
Koh?
another story. I'm not teaching the ones with just a 1 because if we have a 1, we just stick a 1 there. What if we got a 4? Then the a value is a 2. Just be aware of that. Okay. In our version here, our a value was a 2. A was a 2. A was a 2. So we have to write that 1 over a value. Okay, go ahead.
Why aren't we plugging in 2x to the fifth power and u over for u?
We
did that for the other problem.
We did right here.
Oh,
I went and
didn't
plugged it
see
back
that.
in.
I didn't see that. I'm sorry.
No worries, yeah. So I did plug it in at the very end. So we always have to plug back into u, get back to your original language. So there's a lot of nuances going on here. So that's why you have to be careful about these problems. Okay. So again, how do we know these are inverse trig functions? Is first, we tried separating it, couldn't separate it. We tried u substitution, that failed. We tried some other bogus stuff, that failed. And you know what? It does kind of fit the scheme of our inverse trig. Now, just to refocus on inverse trig, if you have a square root with 1 minus u squared, that's going to be a sine inverse. If there's no square root, and see that's a plus, that's a tangent. And if it's u on the outside and u on the inside, that's going to be a secant. Okay, so let's go ahead and do a secant one now. Let's do an easy secant and then we'll do a hard secant. Yep, easy secant and the hard secant. Okay, let's do easy secant first. Now, careful, secant does have absolute value, so we're going to have to remember the absolute value sign. Okay, so we do, here's our problem, integral of 8x 4x squared 16x to the fourth minus 1 dx. Okay, so if you walk into a room and you see this, you're like, what the hell is going on here? Okay, and again, we can try our tricks. We can try all our u substitution tricks. We can say u is equal to 16x to the fifth, so fourth minus 1. That's 64x to the third. I don't have x to the third anywhere to cancel out. So I know, okay, that is not the right path. And then we're stuck with u sub. U sub is going to be 4x squared. And here's a hint here. Sometimes that's obviously what this value is here. Because the model is u on the outside and u squared on the inside, you can see that this squared gives you that inside 16x to the fourth. So just else FYI, our a value is 1, right? That's going to be a 1 here. All right. So let's go ahead and simplify this. If u is 4x squared, du is equal to 8x dx. Now, why do we need to do u sub here? Why do we need to do that? Is because of this guy. This is not in my identity, right? I have a 1 up here. So 8x is not in my identity. So let's go ahead and start subbing stuff out. Integral of 8x over 4x to the squared, square root of u squared, right? U squared was 16x to the fourth minus 1. Our dx is being switched with du over 8x, right? That's where we got this part here. And you can nicely see that the 8x and the 8x nicely divide out. Clean.
Hey, Mr. Ko, wouldn't you change the 4x squared in front of the radical to a u?
You got it. You got it. And that's where this next part comes in. We're going to take a look at it, and we can see that the x squares nicely cancel out. No more x's. But that 4x squared there, we're going to substitute this guy here, with what? A u. Because 4x squared is equal to u. Rewriting this, it's the integral of 1 over u squared of u squared minus 1 du. Take a look. That is straight identity. Okay, the goal is to get back to our identities.
So we can have two u's.
Yes, because this identity, let me jump up here real quick, I'm sorry. What I wrote it, right, I wrote up here. This one here has a u on the outside and a u on the inside. And unfortunately, my example was you're in prison looking out. You're trying to get as close to freedom as possible. That is secant.
So in these problems, there will always be two u's.
For secant, yes, one on the outside, one on the inside. Okay, one on the outside, one on the inside. Okay, let's continue the problem. This is straight identity, running out of space. This is equal to secant inverse, okay, of, don't forget, it's 1 over a, which is going to be 1, and u over a, which is, u is 4x squared over 1, and the top has to be in absolute values, plus c. Simplifying this to make it look a little bit nicer, I don't have to write the ones, is secant inverse of absolute value of 4x squared plus c. Now, do I really need a 4x squared in an absolute value? No, if x was a real number, x squared will always be positive and 4 is always going to be positive, so we really don't need the absolute value sign. And FYI.
And u subbing just the 4x squared wouldn't work, right?
If I just subbed ux as a 4x squared, do you mean at the beginning of the problem?
Yeah, just like the one that's outside of the
Sure.
root.
If I call this just u to begin with, what about all this rest of the stuff? If I did u as 4x squared, sure, it would cancel out this guy here. But you still end up with a square root with a bunch of x's inside. So there's too many variables for us to take the integral. Whenever you take the integral, you should only be left with one variable, and that variable better be the same as this dx x or du or d whatever variable that you want. Okay. Just as a side note, just to answer that, if I say sine, the integral of sine u dx, though it looks okay, this u and this x do not work. Okay, they have to be the same variable.
Mister, are we also gonna do definite values with this?
Yes. So once you're done with this, then we plug in our a and b. So you might only get a few of those questions, because by the time you get here, you're tired out. Your stamina is done. Okay. But just FYI, if this was a definite integral, we would just plug in, let's say 0 and 1 at the end, whatever it is. And it has to be something that you can take the secant of, secant inverse of. Okay? Because remember, secant inverse takes sides and makes them back to angles. So it's a little more difficult there. All right, so let's do a fugly one about this. Maybe I shouldn't use the word fugly, but okay. This one's going to look a little bit ugly. It's going to be the integral of 10x over 5x squared, square root of 25 x to the fourth minus 16 dx. So does this look like tangent? No. Okay, tangent doesn't have any square roots. Does this look like sine? Well, for sure, sine, remember, it was 1 over 1 minus u squared. So u is on the backside. The u was negative, right? U squared was negative. So maybe not. So this probably might be secant. Now, one way to take a look at that is if u was 5x squared, u squared is 25 x to the fourth. Hey, yeah. So this is probably going to be secant for us. And just to say, what's my a value here? Looking here, a is going to be 4, just to make sure I do know that. All right, let's pick up our u. If u is 5x squared, du is 10x. Oh, baby. 10x and 10x, right? This looks like it's cleaning up a little bit. We have the integral. I'm going to rewrite everything. 10x over, I will make the 5x a u now, square root of u squared minus 16. Okay, I will do that. And then our dx became du over 10x. Is everyone okay with how I wrote that? I'm skipping a step here. This should be du over 10x, just to save time, right? Just to save time. We were going to divide it anyways. 10, 10. And then we have our straight definition now. Now, I would say from here, you could go ahead and take the integral. But if you want to rewrite it, to make it look a little cleaner, 1 over u squared of u squared minus 4 squared, to make that a little cleaner, du, we can use that as our identity of 1 over a, which is now 4, secant inverse of u over a, which is u is 5x squared over a, absolute value at the top, plus c. And just to reinforce, hey, do I really need absolute value since it's 5x squared? I don't, because x squared is always going to be positive. Okay, just FYI, in case you ever see that on the test, you might see them get rid of it. Where do you get the 1 over 4? Great question. The identity for this is a 1 over a. So let's go back and look at our identity quickly. Sorry, jumping back to the top. The identity here is 1 over a. Okay. So we just copy 1 over a. Don't even overthink it. There is, again, if you guys have a book that shows the other identity where it's, some books they'll always show this identity. They'll say 1 over u square root of u squared minus 1. And it's a 1 instead. And if it's a 1 instead, that's fine. And the reason why they put a 1 instead is because they actually factor out that value. Okay, they factor out whatever a value that is. They factor it out. It's kind of a cool move, but I'm not going to go into it. We don't have time. All right, that's actually it. Do you guys want to try any more of these? Do you guys want to try any more of these? Do you guys want me to try a sine, secant, or tangent. Are you guys kind of okay? Good to go? All right. If you guys want to stick around, you guys can stick around. If not, you guys can go and get started on the CUDA. And the CUDA is pretty much this stuff. Okay.
Thank you.
Thank you, Mr. Ko.
Have a nice
guys-
day, Mr.
every day.
Ko.
Mr. Ko, have a good one.
Bye, Mr. Cole.